Good afternoon, everyone. I hope everybody is fine there, staying at home. Be safe. Today we are going to discuss about the phase log loop, that is a part of Unit 5. In this phase log loop, we are going to discuss about what is a block diagram of phase log loop, then what are the modes of phase log loop, and the operation and working of phase log loop. So as we all know that we have discussed about IC 555 timer in the previous class, then we are going to discuss about this phase log loop, and the next criteria is that we are going to find out how the phase log loop is going to be used, where actually this concept of phase log loop, which is in short we can write as PLL, the full form for that is this part. So what is actually the phase log loop? It is one of the vital block in linear systems. Whenever we use any types of linear systems in the communication part, this phase log loop is widely used. And the next thing about phase log loop is that it is very much useful in the systems like radar, in the satellite, in FM, different types of communication systems. This is mostly used because it provides a phase detector, the filtering and the controlling over the voltage parameter. So what actually the next concept in this, we are going to learn its block diagram of phase log loop. As you can see over here, it consists of the following three blocks. First is what? Phase detector is there. Second is active low pass filter. Third, what we are using? Voltage control oscillator, which is abbreviated as VCO. So in this three parameters we are using. As you can see in the block diagram, it consists of phase detector, that is passed to the active filter, then it is passed to the voltage control oscillator. So what is the input signal we are giving? It can be chi in of t. This is the input function which is continuous in time. So then we can write over here is f in of t, that is the input frequency which is varying with respect to time, that we are passing to the phase detector. And what is the use of this phase detector? It is going to get the applied input signal and it is passing over there, then it is passing to the active low pass filter. What is the use of this active low pass filter? It will allow the lower frequency and attenuate the higher frequency component, that we are passing to the voltage control oscillator. Here the voltage controlling of the output signal is going to be obtained. Then we are giving the feedback signal. Again from here we are passing a feedback signal to the phase detector. So now we'll see what is the use of each block, why this block has been used, and what are the application of each block by giving a lock signal, a lock loop signal for our phasor form or phase lock loop signal. So as you can see here, it is a phase detector. The use of phase detector is that we are giving the input signal F in. By the name itself, it implies that whatever the circuitry we are using in this, it compare the phase of two signals. Whatever the signals we are giving, it will compare that two signals and generate the voltage according to the phase difference between the two signals. So whenever we are giving any two types of signal, when we want to get the phase of these two signals, when we are comparing it, we are going to get from this end. Then next we had the filter. So as already have said you, the filter is used for providing the, as I'm using over here is low pass filter, it will allow the lower frequency component and it will attenuate the higher frequency component. Then next we will be having VCO. What is the VCO stands for? Voltage control oscillator. Here the voltage control oscillator is a part of the circuit which generates the radio frequency signals. That is normally what is that? Consider as the output loop from the frequency, that is travel and control the operational frequency. Whatever the frequency band we are getting from this, it is going to get from that. The next thing is that again we are giving the loop to it. That is nothing also used for the giving the signaling over there. That is nothing but the loop filter. So what is the use of this? This is also used to provide the filtering. So what it does, this filter is used to filter out the output from the phasor. So whatever the phase is there, it will compare from there and again it will fed back to the input side, until and unless they should have three different types of voltages. What were those three voltages? I'll explain you in the next slide. So as you can see over here, we are going to get the working, how the working is there for phase log loop. First thing is that phase detector, what it used to get, it goes to get the DC voltage which is proportional to, as I already have said you, it is going to compare two types of phases. One is from the input, another is from the feedback. That two comparison and the phase detection that can be done by using the phase detector. The next one more use of phase detector is to give the multiplier, and it will produce two frequency components, where it is going to produce at the output side, where it will take, it has two input, F in is there, chi in is there. Out of that I am saying we had input F in and we had the output F out. That two they will compare it, that is comparison is done by the phase detector. Next thing is that we are going to get an active low pass filter. So it is also used DC, since we are giving DC voltage at the output side after removing the higher frequency component, because it's a lower pass filter which is the active one. It is going to remove the lower frequency, it will allow the lower frequency component and attenuate the higher frequency component. So attenuation in the sense it won't allow the higher frequency component after critical frequency. So we know this thing, low pass, high pass, band pass and band stop filters, all those, out of those four types of filters we are using here is low pass filter. So and also use most important application in our PLL phase log loop is, it is also amplify the signal. So whatever signal we are giving, it is go to amplification as well. Next is that a VCO produce a signal which is certain frequency when there is no input applied to it. So what is the use of VCO also? It's a voltage control oscillator. The name itself is oscillator in the sense it will going to give the output when there is no input as well. That's the reason we are saying that it is a voltage control oscillator.